Yeah, I haven't been back here since I moved here almost 3 years ago. Yeah.
Morning, everyone. Welcome to the webinar or online workshop. We'll just wait a few minutes for people to join and then we will get started. Looks like the people coming in have plateaued, so we'll get going there. So kia ora, good morning, everyone. Welcome to this online workshop brought to you by the Life Cycle Association of New Zealand. For those of you that are new to LCANZ, we're an independent special interest group for LCA in New Zealand with a representative membership including industry, practitioners and researchers. LCAN's mission is to provide a focal point for life cycle assessment and management work conducted in New Zealand. It's our aim to promote networking and knowledge sharing between organisations and people through events just like this one. So within LCANZ, we have a best practice working group, which is made up of LCANZ members who work to support LCA practitioners in New Zealand. My name is Jackson McFarlane, and I'm hosting alongside my friend Ray Mohan. We're together the co-chairs for the best practice working group. I'll post a link in the chat with the LCANZ website for those that would like to learn more. But today we are here to discuss the role of AI in life cycle assessments. We've got a great lineup of speakers that have very kindly donated their time to share with us today. A couple of quick housekeeping notes, as is fairly standard these days with webinars and online workshops. The cameras and microphones for everyone are turned off to avoid interruptions. But please, as the speakers are talking, post any questions that you have in the Q&A function at the bottom. We'll run through the 4 speakers that we have, take a short 5-minute break so everyone can stretch your legs and use the lavatory. And during this time, we'll run a quick poll as part of sort of the workshop element. Well, then Ray is going to run a panel discussion using your questions, and then we'll wrap up at the end using some notes from the poll. So that's enough from me. We'll start off with our great lineup of speakers. So first we have Andre Mazzetto from AgResearch. Andre.
Oh, thank you, Jackson. I'll start sharing my screen. Oops, I cannot share my screen. Saying host disable attendee screen sharing.
As always, 1 second, everyone.
Well, we can ask AI for help if you want.
Yeah, that's great. Other than that, I think everything should be working. I haven't tested this now to know, but there is probably enough.
All right, try that.
Oh. Okay, you should have the screen with the LCA logo.
Yeah.
Yes.
Cool, thank you. Thanks, Jackson. And thank all for the invitation as well. So just one note, this slide is actually outdated. AgResearch doesn't exist anymore. About 7-8 months ago, we merged it with other Crown research institutes, and we are now the New Zealand Bioeconomy Science Institute, which is a pretty long name to put under that logo. So we're trying to find a way to update it in the meantime. Here, our job is to work on the science of LCA, but also we operate, AgLCA operates as a small business unit, and we do commercial work, especially on the pastoral area, so dairy, beef, sheep, deer, and other interesting food production systems. The idea is are we using AI, or we plan to use AI in the future as well? And I'll run through some things. The first one is just remembering a friend of mine. He said, don't worry, AI won't take your job. Is someone using AI that will take your job? And I think that's the idea. It's not like we use it or not. Is how responsible we are using it. And I'll get back to that at the end of the presentation. So the first one is we use that as a coding AI as a coding partner or a coding buddy, if you want, just to give some idea of how the process was before. So we had for our projects a data template that we shared with clients or we use internally. We did some initial modeling on Excel. That's because we're dealing with animal production systems. It's very hard to get all the data and model the animal behavior or the animal physiology inside softwares like SimaPro and Gabi and OpenLCA. So we did some initial modeling on Excel, did a final modeling on SimaPro, getting the emission factors, gathering the processes, and then we had our final results, that we use for reports, figures, and etc. What we've done we started that about 5 years ago, was to code in R, which is a programming language, all this middle step. So that old process that was like not scalable, prone to errors or human errors of copy paste and those type of things, now becomes scalable, becomes reproducible, and fast. So if you have one farm, it runs. If you have 10,000 farms, it runs the same process and is the computer running. And that's, I think, the big bottleneck in LCA is not the theory, is not the equations or the emission factors, it's the implementation itself. And that helps. We then build an API, which make things even faster, but both for our clients and for ourselves. So the API acts like the waiter there and gets your order, brings to the chef, which is the DR code, and then brings the result or your meal to yourself. So this was done with some help of AI because remember, we started 5 years ago, and I put this slide to an internal presentation for our team recently. Just to remember that AI is quite recent, and 5-6 years ago when we started doing that, actually AI was not very trustworthy. There was not many people using it, and now it is very good, especially for coding. It's one of the safest ways of using AI, actually. So what happens for us is that it is helping us to express our scientific decisions, our models more efficiently. But one caveat here is that the system boundaries, the emission factors, the allocation rules, the assumptions, they're all defined by us. AI doesn't choose them. So basically, how we're using as a coding partner is writing more reliable code, write more robust code, helping with documentation. I mean, it's not perfect, but it does a good 70-75% of the job. Automating reports, very hard to do individual reports for like 10,000 farms. When we run them, AI can help with that. And also, what we're trying to explore in the future is about machine learning. You know how AI now is training the new generation of AI. It's not us training anymore. It's like AI is training itself. So that's how can we train the models to work more independently of us flagging potential mistakes, improving itself, etc. The second point is AI for infrastructure. That's something that I'm not currently working on, but I think it's important for us. It's important for us to start thinking about it. First point is data harmonization. I think when we start working on LCA, usually you choose one of the softwares. It becomes kind of a religion. Usually you choose because someone else they were working with was using the software, and then you start judging people based on the software that they use. I know that some of you already have an opinion of me just because I said SimaPro. But the problem is those softwares, they don't communicate with each other. Outputs of OpenLCA doesn't work with inputs of SimaPro, that doesn't work with Gabi, that doesn't work with, and it's very hard to collaborate, very hard to work together with people in different platforms. So that's one place that AI can have an input. AI is very good on structuring messy information. So mapping input and output from different softwares, detecting these structural mismatches, and making collaboration faster when we're having people using different LCA softwares. Another one is data curation. To do what we are doing, like using the code and removing emission factors from CIMA Pro, you need a special license for that. And of course, it's a bit more expensive than the normal license that you have to pay. So I myself went down the rabbit hole of finding how good are the inventory data. And this paper here is very good, provides a good picture of it. So what the authors did was to go to different databases like EcoInvent, Gabi, and others. The gray bar there is the number of processes that they sampled. Of course, it's very hard to do this type of job for all the processes on the database. So they sampled a number of processes, around 300. The yellow bar is the number of processes with findable sources, meaning that you can go and search and find the reference. And the green bar is the number of processes that you can find the reference and you can see and you can access the reference. So it's a bit appealing that there's not many of those there that you can actually find the reference for the process. So how AI can help with that? Imagine AI going through hundreds, thousands, millions of papers, reports, EPDs, books, and tracing that data, getting data from figures, from tables, from text, and not depending on humans. Again, AI is very good with mass information. So sounds too good to be true, but is actually already being done in China. So the Tiangong initiative, they are doing this scraping the Chinese database, and in 1 year they have about 4,000 unit process with daily updates. And the best thing of that is it is free. So this is something quite exciting, and I would like to see that for the rest of the world as well, not just China. Just to finish some risks and guardrails or mitigations of using AI. The thing is, it helps us to build models, but also reduce the barriers of building bad models. So what we want to avoid is these black boxes, LCA platforms. We want to avoid automated system boundaries choices, or the silent assumptions, things that the practitioner or the scientist doesn't take care of. And I think the most important is that I say the team all the time here, you can have the most beautiful code, efficient, nice to read, easy to read, but if it's wrong, implemented the wrong logic, then, well, it's wrong. Doesn't matter. Some ways to control that is basically keeping our accountability as practitioners and scientists. So the most important of all that list, you have the documentation, the validation, but to me, it's not automatic acceptance of AI output. We still need to triple check sometimes what is coming out of there. Finally, last one, and I don't have any more slides, is what is the future of that? And coming back to the beginning of presentation, it's not if we should use or we should not use, it's how responsible we are using. And it will help. It doesn't change the principles of LCA. It changes how efficiently we can apply the principles. So that's my final message here. Is not our discipline is not defined by how much we use AI. It's how responsible we are of using the AI. Thank you.
Thank you, Andre. That was great to see how people are using AI in practice for LCA. Next up, we have Kelly from EPD Australasia.
Great, thanks Jackson, and thanks Andre. I really like your idea of responsible use of AI. It's a bit like anything that comes with risks, as we need to use it responsibly. Thanks for inviting me to come along and present today. I'm going to talk about artificial intelligence and environmental product declarations. So I guess just a short introduction to EPDs and EPD Australasia. So for those that perhaps aren't aware of how EPDs work, they're based on an ISO standard 14025, which is grounded in LCA methodologies, and they are a production of a set of environmental indicators to a standardized set of instructions and rules to allow comparability, and those results must be verified. And the important thing about that standard is that once all this is done, it must be registered with a program operator, which is what we are. So EPD Australasia is defined as a program operator in that standard. And that data that's registered with us then must be publicly available. So that's where AI becomes important, because it's putting that data out available for AI to read. So EPD Australasia has been in operation for almost 12 years, and we were set up in partnership with the international EPD system based in Sweden. So why AI matters right now in EPD? So we all know AI is a rapidly evolving landscape. I believe there's few people that know how to use it really effectively, but there's a whole lot of people who are dabbling in it. The reason that AI is important to us in our organisation, what we do now, is because you'll see in this graph over the last 11 years, we're starting to experience exponential growth in EPDs, the interest in environmental data. So AI can have a really important role in assisting efficiency, as Andre said as well. But also with this exponential growth, we have the risk of amplified error, and therefore AI can also assist us in our QA processes as we grow. So I guess there's two key points that I'd like to get across, is that EPDs as verified environmental data are important in an AI world because they provide good quality verified data for AI to draw from. And the second thing is, in our organisation, the ability to use AI for that QA to ensure the integrity of data is really important. So how does AI interact with EPDs? The answer is really through all aspects. AI can interact and be used. So as Andre said, right back at the data collection stage, then translating your LCA results into EPDs, using AI to ensure standards are met for EPDs. I know verifiers are using AI as an extra sense check and to improve their own efficiency and accuracy. As I've said, QA is a really important area in which we as an organisation can be using AI. And then obviously in terms of the use of the data, AI can then enhance the data to go into further operating systems, supporting better decision. And all of this, of course, comes with risk, as we said. So why are EPDs important? EPDs provide verified, transparent data. It has to be in the public domain, therefore AI can read it, and we're protecting against greenwashing. So what we're seeing in our organisation is an increasing sort of mining of EPD data into third-party platforms and tools. It's likely that this data is being used in ways that we aren't even aware of yet. We are certainly alerted to some ways it's being used, but not all. So having really good data in there to allow these tools and platforms to be really useful. So there's a few things that we're looking at sort of partnering with. One is the digital product passports, which take the EPD data into these digital product records that are linked to the EU legislation, which will be important for some manufacturers going forward. And then I've just got an example here of the Low Carbon Materials Hub. If you haven't heard of them, I'd encourage you to look them up. So this is an organisation that is using AI to read EPDs and take the data out and put it in a really easy to use format for decision makers. They have a really advanced AI reading capability, and through their processes, they are able to sense check data, run comparisons, and feedback any issues to us. So this use of AI by a third party is improving the data integrity overall. And really nice to know also that in the future they are going to look beyond just those carbon figures and other indicators as well, which we really encourage. So what can't it replace? I mean, I think we all know now that it's not going to replace humans. Obviously, LCA practitioners can use AI as a tool in the background data gathering, but importantly, that sort of human judgment and sense checking is really important. AI will not replace the standardized methodologies that need to be developed and grounded in technical expertise. And it can't replace, obviously, governance systems and processes. So I guess in summary, we don't see AI as a threat to EPDs. We see it increasing the importance of getting good quality verified data out in the public domain. We see it as a tool for increasing efficiency to support our exponential growth in this area and getting that data out there. And we're looking at actively working with others who are using AI to work in partnership with them. So last word from me is that AI needs credible data and EPDs provide it. Thank you.
Thank you, Kelly. Really interesting to see common theme there between yourself and Andre around transparency and reliability, and its links to AI, which can be both positive and negative depending on how it's done. Yeah, and a reminder to everyone, please keep throwing any questions that come up as you're listening into the Q&A function at the bottom so that we can use those later. Next up, we have Barry Lynch from NEZO.
Apologies, Jackson. I'm just having problems here trying to get this to share. If you just bear with me 2 seconds. And maybe move on to another user. And what I'll do is I'll try and fix whatever's going on here.
Yeah, no problem.
Yep.
Andy, do you want to take over? Andy Hill from Planet Price.
Yeah, no problem. Thanks, Jackson. Thanks, everybody. So my name's Andy Hill. I'm the founder of Planet Price. We're a technology startup, B Corp, based out of Australia. And our world is working with procurement and sustainability teams to start to profile the environmental impact of their procurement at scale. So we're not really sort of at the EPD or LCA level. What we're doing is helping organizations understand the environmental impact of their supply chains. And we do that through the Planet Price algorithm. And Planet Price is an AI-enabled algorithm to quantify the environmental impact of everything that an organization purchases and express that as a single monetary figure or a shadow or what we call the Planet Price. So typically what we're doing is working with organizations to ingest hundreds of millions, if not billions of dollars of procurement data. And then we're using AI to start to progressively calculate environmental impacts at the highest level of fidelity and accuracy that we can. Now, obviously, that depends very much on the quality and the nature of the data. So we'll quite often start with spend data. And as you know, with the many spend-based emissions factors that you can apply. So using those spend-based emissions factors, we're able to develop heat maps that help people explore their supply chain and understand where the hot spots are and where they can focus further. And then that's where we start to get down to product data. And in the last sort of 9 months with the all of the amazing advances in AI, we've started to build out AI tools to do what you might call product screening footprints. So it's definitely an LCA, it's certainly not an EPD, but it's sort of like a starting point for procurement teams to understand the footprint of what products that they buy. And some of these organizations might be buying tens of thousands of products. So as you can understand, it's going to be extremely hard with a sort of bottom-up LCA approach to give them that data. So let me just show you how that works with a simple example. Can you tell me, are you seeing a screen? Nothing yet?
Still your beautiful face, no sharing screen coming through yet.
No, okay, let me just, there we go.
Yeah, there we go.
Excellent. So this is the platform, and this is Sira, our AI tool. So let me just take an example. Let's say I've got a Bosch 18-volt cordless drill. So based just on a description, and this description might be, part of a purchasing transaction record. It could be an invoice or a purchase order. I can just put a text description in. Possibly I may have a image. So let's put an image in. So I've got a photo of this cordless drill. And it's actually quite interesting how much the image processing does help the AI. Even better, I might have a PDF that is a brochure or a technical specification so that the AI can also read that and pull out the parts that it needs. But let's just go with the photo and the description, and we'll give it to the AI. And so what it's doing is it's actually sort of coming back and saying, can you give me a little bit more information? So I might say it's asking me a bit about how often do I use the drill? Let's say weekly. What do I use it on? I don't know. How often do I charge? And then it's asking a little bit about end of life as well. So let's say it's part of an e-waste disposal. So whatever information you have, we can feed to the AI and it will go and do the calculations. So what it's done is it's calculated the materials. Let me just scroll up a second. So it's calculated materials, transportation, use phase, and end of life. And the headline figure here is a planet price of $10.11. And what's driving that is the usual sort of indicators. So obviously we've got global warming, we've got nearly 17 kilograms of CO2, but we've also got water, we've got land, we've got various forms of pollution. So standard sort of indicators. And what we do with Planet Price is we obviously calculate it in its natural units, so kilograms of CO2, but then we apply a shadow price or an environmental price to each one of the indicators, and then we add the whole thing up, and that becomes the Planet Price. And the reason we do that is just to make it simple for procurement people, so they've got a single metric that they can start to use to understand materiality. So, if the Planet Price of the Bosch drill is $10 and I'm selling or buying 1,000 of them, that gives me a way of sort of keeping track and scoring what my overall impact is as part of my procurement profile. So we can look at it by impact, we can look at it by phase, so you can see materials, use phase, transportation, end of life. We can sort of break that down. And the way that what the AI has done is it's from the photo and the description or any other information I've given it, it's broken it down into the major components. So we've got a battery pack, transmission, drive system, etc. And then for these components, it's estimated the mass So we didn't actually even tell it the mass of the drill. It's estimated that from the photo and what it knows about Bosch drills anyway. And then from that, it's sort of allocated the mass for each one of these components. So we can look at it as a mass, we can look at it as a planet price to see what's driving the impact. We also generate a confidence factor. So the AI scores itself at every stage based on the input data and how confident it feels about that, and also the matching to our databases and whether it feels like it has a good match there. So we can look at it from a confidence point of view, as well as all of the different impacts. So if I want to look at it from a toxicity point of view, it's the battery is probably driving a lot of that. If I break it down a little bit more, let's have a look at the materials piece. So what it's done actually is actually we'll just jump in here. This we find very interesting. This is the scratch pad. So it's giving you sort of an insight into the reasoning of the model, and we find this very, very useful for debugging and understanding whether it could potentially be hallucinating or using the wrong assumptions. So you can see this is kind of the thinking process as it goes through and pulls out all of the numbers and then sends those numbers to the calculation engine. So part of that process is it creates a component hierarchy. So again, just from the photo and the description, it's looked at the major sort of components and the materials that go into it. And then from that, it goes into this sort of bill of materials grid, which goes off and does all of the calculations. Along the way, we keep a change log. So everything that the AI does, every assumption it makes is logged and tracked. And then if I wanted, I could go in and I could improve this data. So I could correct it if some of the assumptions were wrong. I could bring in LCA or EPD data to replace some of the AI calculated numbers. So and all of that is logged so that you've got a full sort of provenance of the calculations. Similar sort of idea with transportation. It's this particular example. It knows a little bit about the context of the buyer, and so the buyer is actually based in this case is in the Netherlands. It's saying it was manufactured in China, and it's looking at distances and the different transportation modes in order to get it to Amsterdam. So it sort of works out the transportation piece as well. And then similar with use phase, it will look at energy, it'll look at components and consumables, and then finally end of life. We look at the likely end of life modes. So that's probably just a quick whistle stop. I think we've got a long way to go with what we're doing here, but I think what we're finding is that the initial results are very, very useful for procurement teams to help them make sense of big, complicated procurement profiles. So we're able to run thousands of products through in maybe just an hour, and the results quite often are scarily good as a first starting point. And with the planet price metric, it helps people understand the hotspots and where to focus, and then from there they can drill down using more rigorous methods and data sets to improve the footprints. But importantly, it's helping the procurement teams understand sourcing strategies, circularity strategies, and overall, ultimately looking for the opportunities to reduce their supply chain footprint. So that's really all I had for now. I hope that was interesting, and happy to take any questions a bit later.
Thank you, Andy. Really cool to see being able to see under the hood there with the AI and how it's sort of working and breaking it down. I noticed it scored itself high in every component of its reliability. So obviously a very confident AI model.
Might be overconfidence at the moment, possibly. We've been doing some testing with RMIT, one of the universities over here in Melbourne, and one of the things we're doing is stress testing it to sort of understand the particularly how deterministic the models are. As we know, AI is not fully deterministic. You can ask it the same question twice, and it may give you slightly different answers, and that's just the nature of AI. But obviously, it's important to understand what is the sort of confidence interval, so that we're producing data that is fit for purpose for the sort of decision making that people are using it for.
Yeah, perfect. Thank you very much, Barry. We'll pass back to you. Take two.
You guys can see it this time?
Yes, we can.
Excellent. Cool. Andy, that was really impressive, mate. I think one of the biggest barriers that we see in what we do is the communication of the information. And it doesn't have real world context, it just gets lost. And it seems to be that, you've multiple different ways of communicating that, which is really, really impressive. Yeah. It's kind of one of the tenets of what we have as well is how we communicate the information and make it usable by an actual average person within our industry. So really, really cool. Really impressive. Cool. Thanks, Jackson, for the invite and the introduction. I'm one of the co-founders at NEZO, of which there are three of us. The one-liner of what we do is that NEZO is on a mission to make construction design smarter. And what we're doing is we're harnessing AI to leverage data into the design process for architects and engineers to drive down the cost of construction by identifying missed opportunities, but also removing or preventing carbon emissions in their designs as well when they eventuate on site. Today, I'll be giving you a very quick overview and visuals on what it is we're doing, why we're using AI, what the barriers are to the uptake of LCA, and how AI is the solution for us to that, and obviously just some results that we're getting as well. So you'll see NEZO here playing up on the screen. It'll loop over and over and over again until I stop talking, which I tend to do a lot of. It's a cloud-based application for architects and engineers, and it plugs into their existing software and their existing workflow. So nothing really changes for them. It passively happens. Most of it passively happens in the background for them. What it does is inside their design software, of which there are three major ones worldwide: Revit, ArchiCAD, and SketchUp, that architects and engineers use. What it does is NEZO syncs via an API with their design software, and it instantly produces an automated schedule of materials and quantities for those materials. It then allows the user to embed data directly into their model. So they're embedding cost data, carbon data, weight data, thermal performance. We're also working on water usage and a few other metrics as well to embed there. The reason we do more than just carbon is because each has an impact on the other. And you have to have a balanced approach. If you don't have a balanced approach, you end up with a project that's either unfeasible to build from a cost perspective, or hasn't got the carbon emission reduction that you were chasing, or it gets you a future compliance. What happens is that in real time, as they sync with our model, they get to see the instant impact of the material choices they've made from the earliest stages of design, even when they're just working with shapes, not full detail. They get to see the cost of what they're proposing, the carbon emissions, and all those other metrics I was talking about as well. But then importantly, they get to explore alternatives without having to design the building multiple different ways, multiple different times. We allow them to rapidly analyze alternative materials and then explore alternative methodologies as well to building the building. Another part of what we do is we automate compliance reporting. So here in New Zealand, we've got the thermal energy reporting H1. We've automated that for them. LCA Quick, which is the carbon report within the construction industry that brands released, also automated that. The Green Star report from NZGBC, their carbon element is automated, and neighbours across in Australia as well, which can be used here as well in New Zealand. What we see out in the industry is that up until now, architects are flying blind to building performance or design performance. They understand compliance around fire and acoustics and structural stability, but they have no idea how much a building costs while they're building it. They have no idea how much carbon emissions are in the building while they're building it. All that information comes way later at the very end stages of design, when they've designed to enough detail that this can actually be measured by an external consultancy, who then tell them they have a problem. They've got to go back into design. They've got to either remove some value from the project or waste time basically exploring options that they don't know again will have an impact until they return to them and get them measured again. So what we see is that making live performance data available as early as possible within the design process actually results in buildings that cost less and emit less carbon and perform better overall. And very importantly to architects as well, they still look great on Instagram. So why is NEZO using AI, or how are we using AI? We're using it quietly in the back end. And to be honest, it's very, very boring. And we don't talk about it much. We tend to show visuals of the results. We don't talk about the AI that's actually working in the background, because what we found is that architects and engineers, they don't want flashy AI solutions that design buildings for them. They want to retain control of what they're designing. The expression that I've heard is that they wanted to do the dishes, not the art. And that's very much what we look at. We have tested some flashy AI front-end analysis for them. They didn't like them. We didn't proceed with them. We concentrate on removing the barriers and the friction to actually running LCA. So to a designer in the industry, so we say an architect, carbon data is extremely messy. It's buried deep within a multi-page PDF, EPD, or in a really bulky Excel database that is full of noise for them. Often that data is provided to them in the wrong unit for what they use, or the wrong method of measurement for what they do in the industry. As a good example of this, plasterboard in the industry is measured in meters squared. It's not measured in cubes, it's not measured in kgs, but in EPD language, it's expressed as carbon per kg. So there's conversion involved. And when you're doing it on thousands of materials in a building with multiple options on all of them, it becomes very complex very quickly, and then continues to be complex because it has that effect on other elements of the performance of the building. So as I said earlier on, you're trying to actively reduce or prevent carbon emissions. You're having an impact on cost. You're having an impact on the weight of your building. So it gets complex really quickly, and it's a huge barrier. There's massive friction for them to actually to overcome. And often they'll just walk away from LCA, because right now in the construction industry, in the design industry, it's not mandatory, fully optional here in New Zealand. The other thing that's at play is that it's early design stages where you have the impact. So 60 to 80% of carbon emission reduction and cost reduction is actually found in the first two stages of design, of which there's 5 design stages. And that's when there's the least amount of detail available to an architect or engineer. They haven't gone into incredible detail in their design, so it's almost impossible to use EPD data because you're working with such high level information. After that, after your early design stages, when you've locked in your decisions and you go all the way to your detailed design and you're ready for construction, you get death by spreadsheet. So the tools that are available, not just here in New Zealand, but right across the world, tend to be Excel-based, really hard to use. You tend to have information in one place that you have to manually transport into another Excel sheet. It takes, for an average practice, hundreds of hours every year for, we say, 3 or 4 projects. If they're only running 3 or 4 projects, more if they're running more projects. So huge amount of time is lost to them, and it's a massive frustration, because what they want to be doing is designing buildings, not actually running spreadsheets and calculating carbon. And what NEZO does is that we embed AI to remove those barriers or remove that friction without them actually seeing it, as I said earlier on. What we do is we crunch the information and we clean the information. So we take those raw EPD PDFs, we take the carbon databases, and first of all, what we do is we extract the data. So remove all the noise, just extract the information that an architect and engineer is actually interested in, the performance metrics. We then clean it by turning it into industry standard measurement. So again, as I said earlier on, that plasterboard goes from meters or from kgs into meters squared across thousands again of materials that you have in your database. We then convert it into design ready information. So what we do is we allow it to be embedded directly into their design model. So turn it into a metric where they're not having to do Excel calculations. We can actually allow them to embed that data directly into their software. We then use AI to solve the early design stage issue of we don't have enough detail. We're working with shapes rather than detail. So as an example, you might have the footprint of a building, the ground floor area that has a foundation that you're not designed yet. Well, what we can do is use AI to build an entire system of complex data sets. So we will say a raised timber suspended floor. That design, with all the data that sits for cost, carbon, weight, water use, energy use, can actually be embedded into that square shape of the footprint of the building. And then they can compare very quickly to a riprap foundation, to a solid concrete foundation, to multiple other formats, and see how they will perform across cost, carbon, and weight. And then decide, right, well, which way is the best way or the best two ways to proceed to the next stage of design. So they're not going down rabbit holes, exploring things in any great detail. They're finding the direction very, very quickly. We're also, where have I lost my train of thought? Yeah, those systems, look, the systems that we've developed just allow them to work way quicker at the early stages of design and make better initial decisions at that 60 to 80% impact point where they're making those big changes without actually just what we see in the industry using experience, using what they did on the last project to inform this project. We've basically pushed far past all that and allowed them to use data to actually make better decisions rather than just relying on their experience. All of that removes the friction. Now, just to finish up, I'll just show you a very quick example of how that data actually supercharges their experience or their design process and how it can make a stark difference or a stark improvement on their project. What we've got up on screen here, and excuse the old visual of the last UI of our app, we haven't got around to updating this yet, is we had a designer and a developer on the North Island come to us. They were building 5 apartment blocks in Hamilton. They'd already got them fully designed. They were ready for putting in for building consent. And they said to us, look, we're a little bit worried about carbon emissions in the future because we've got 65 more of these to build. It's a portfolio risk for us. We may not be able to replicate these buildings in the future, and we want to know what the actual impact in the future is to us. We ran an analysis for them, and what we found was, using data, we found them $750,000 in savings on their project. We eliminated 3,750 tons of carbon emissions from their 5 buildings, and that we reduced the weight of their buildings by 1,000 tons each, which allowed them to, in theory, to build 2 stories higher. That was a building built on experience without data. When you bring data into it, it starts highlighting the fact that we're missing opportunities consistently in every single project, and there's better outcomes possible. This particular build never went ahead. They went back and they redesigned the building with the information that came from AI and crunching the numbers and providing data, and have now finished 3 of those buildings to 7 stories, and the building the other 2 to 5 stories. That's what's possible when you use AI and data, when you're not relying purely on experience and instinct and actually leveraging data. That's it for me. Thanks, Jackson, again, for giving us the opportunity to show what we do.
Thank you very much, Barry. Really great to see AI being used there in practice for designers, and I think a really nice wrap up for the speaks we've had so far, which has gone from excuse me, the initial early stages of LCA research through to sort of existing documentation, how it can be used, and then 2 great examples of different software platforms that are using that data and AI to help with both procurement and design. I think especially that last point with yours, Barry, as someone that works in the carbon and design sort of building space, there's always the request to attach a cost of carbon. It's something we often talk about that's really, really hard to do. And it was awesome to see both the Planet Price and the NEZO platforms doing that in 2 different but quite intuitive ways around having cost, which is something that inherently everyone in business understands, and it's a lot easier to communicate rather than sort of a hypothetical kg of CO2, which can be quite hard for people to sort of intuitively understand. So a lot of great similarities and really useful tools. So what we're going to do now is have a quick pause. I'll throw up a poll. So it's here in Otautahi, Christchurch, 9:52. So at 9:57, we'll jump back on. Please, in this 5 minutes, complete that quick poll. I think there's only 6 questions. It's not too much. Stretch your legs, deal with that email that's sitting in your inbox causing you anxiety, and then we'll come back for the Q&A panel discussions. Also, during this time, feel free to throw some more questions into that Q&A. So thank you again to all our speakers, and we'll see you again soon. Hi everyone, welcome back. I'll leave that poll running for a little bit longer. I can still see people are submitting some questions, and I'll pass over to Ray for the next phase.
Awesome. No, thank you, Jackson. No, and thank you again to all our speakers. So we've got a few questions that have come through the Q&A. But to kick things off, I think, as you know, as we touched on with the different presentations, there has been that common thread around sort of transparency, but then also trying to extract sort of data that we can then put for different purposes. And I think I'd like just to put this to sort of everyone that we've got in the panel. If someone was in New Zealand trying to start incorporating AI for their sort of respective sustainability journey, where do you think they should begin? Or if you've got any sort of lessons learned that you would like to share, that would be awesome. I might just start with you, Andre, if you had any kind of thoughts on that.
Sure,
Christian?
thanks, Ray. What we have is when we started here at, formerly AgResearch, Bioeconomy Science Institute now, was the need to start upscaling the analysis and making it faster, making it better. So we got in touch with our IT and data team. So they pointed us to possible solutions and things that can help. And also you have new generation, new people coming and improving as well. As I mentioned on the presentation, we have a team of people now that they make me feel old sometimes, which is great. So they are making things better.
Awesome. Thank you very much, Andre. Andy, what about you?
Yeah, I think our experience is maybe a little different because we tend to start at the sort of big picture. So we take a top-down approach and then a bottom-up approach after that. For a lot of our clients, it starts with Scope 3 reporting. So the new sort of regulations in Australia, ASRS, people are having to, for the first time, report their Scope 3. And that's a huge data challenge. People find that they really don't have good procurement data. They don't have good activities data, but, they're going to be audited and they have to put, robust numbers forward. So that's a great starting point, I think, for people to really just look at their entire organization, their supply chain, their operations, and then start to really look at the hotspots and then drill down into those hotspots and start to bring LCA and EPDs and more accurate methods. But I would encourage people to look at the big picture first. I also think, personally, we really need to look beyond just carbon. There's with Planet Price, we look at 10 different indicators and we weight them, to come up with the Planet Price. And typically we find that the carbon piece is something like 15 to 25% of the overall Planet Price. So from a sort of sustainability planetary boundaries perspective, if we're just carbon focused, we may be leaving 75% of the problem, or if you like, 75% of the opportunity on the table. So whilst it's hard, I think it is important that organizations start to shift their thinking beyond just carbon.
Thank you, Andy. And I think just the point you touched on as well around, being able to do that early screening and having that ability to understand before you sort of go further down in decisions. I think, Barry, you sort of touched on that as well with the tool and some sort of the barriers you saw. Have you got any insights, I guess, from, some of your clients and the architects and designers that have incorporated NEZO on what they found with incorporating the AI into their sort of design work?
Yeah, just confusion, being overwhelmed by just the amount of data that they have to deal with. It causes most people, as I said in the presentation, to just walk away from it because it's too hard basket. What you also find happening is you end up locking the experience or the knowledge up one person within a practice. And what we hear time and time again from architectural firms, larger ones in particular, is that they train somebody up and they give them all the knowledge. They become very valuable within the industry and they move. So it's got to be democratized to the point where everybody can do it. It's got to be made easy, remove those barriers, remove the friction.
Thank you, Barry. And Kelly, no doubt, I guess with EPD Australasia, you'll come across a whole range of organizations as well that, through their development of their EPDs have incorporated AI at those different stages. We've talked about screening, but also, I guess, with the data collection when it starts to be around building the LCA itself. What are some sort of insights or I guess recommendations that you'd be able to share to such organizations looking to kickstart their sort of EPD journey?
Yeah, I mean, I guess, the opportunity to be more efficient in the data gathering starting point is a really amazing opportunity that AI provides us. But with the, I guess, safety rails of really good verification. So I think by all means use this tool that's out there to improve efficiency, but that makes the verification step as important as it's always been, but still important at that step as well. I guess from my personal experience with AI is really that it's only as good as the question you ask it. So I think originally you said, Ray, what would be your advice for people starting out? And that's to actually get some training, because the training and the questioning of AI is really will determine how good the output is for you. Yeah.
Awesome. Thank you, Kelly. And I think we've got a question that has come through just around EPDs as well. So I might sort of pop a second one to you. And I guess around sort of getting, or I guess cost barriers and things like that around starting off with EPDs, how do you see AI reducing that cost or reducing that sort of barrier?
Yeah, I think the short answer is that it should absolutely reduce the costs. So for those that have been on an EPD journey, they'll understand that there's, an investment into the background LCA work, whether that's internally or through an LCA consultant. So that's one part. We've talked about how AI can assist efficiency there. We've talked about how AI can assist verifiers to verify the EPDs. And I think that is one area that's quite advanced and therefore should assist in reducing the price point of verification. In terms of what we control the registration fees and that sort of thing, but we work with the consultants and the verifiers, acknowledging that we all need to work together to reduce the price point. So with the growth, using AI to increase efficiency, the answer it should be absolutely, it should reduce the overall price point. Yeah.
Awesome there. Thank you very much, Kelly. And I think we've got a question here just around for Planet Price, actually, Andy. So just when we look at the decision support output and you're doing the sort of impacts, how does it work when you're comparing materials like steel and timber? And I think also sort of looking at biogenic carbon.
No, it's a great question. So the tool is cradle to grave, and ultimately we want to make it cradle to cradle. So starting to think about circularity aspects and benefits. Most of the retailers are most interested in that sort of A phase, the materials manufacturing, maybe the transportation as well. The sort of use phase and end of life, they have less control and less knowledge over. So they do. The focus does tend to be on that A phase. In terms of biogenic carbon, we treat it as a sort of temporarily stored carbon, and then what happened, from a sort of Planet Price accounting perspective, or through the different phases, and then depending on what happens at end of life, is that carbon actually released or not? So we sort of track it through the life cycle that way.
Awesome. Thanks, Andy. And I think there's also been a question around, with the tool producing a single monetized sort of impact, how do you help your users understand what sits behind that value that's sort of calculated?
Yeah, that's a great question as well. So we do allow people to apply their own weighting factors. So specifically, if they've got a carbon shadow price that they're using internally for investment decisions, then they can pull that in. But with our defaults, we've sort of scanned the scientific literature, and we've tried to select what we think are defendable, robust, sort of pragmatic median values. Most of that has been sourced from CE Delft in the Netherlands. If you've come across that consultancy, they have a handbook of environmental pricing. So we've tried to be fairly pragmatic about the weighting factors that we've applied. I suppose, areas of research for us, we're updating the algorithm every year based on sort of what's happening with the science and the economics, and things like water. We apply a sort of water scarcity factor in there. It's currently only at a country level. Ultimately we'd like to get sort of right down to a watershed level. So, one of the things I think we're seeing, and this is again perhaps where AI can really help, is that there's real tailwinds, I think, in terms of there's just, it feels like every week there are new data sources popping up around the world, and new data providers who are providing really great data. So we're looking to sort of ingest the very best data sets we can, and planning for a world where everything has an EPD and we have perfect data sets, and we can we can use things with a lot more confidence.
So thank you, Andy. And I guess just on the note around, the existing sort of data sets that are coming out, I like to go to you, Barry, in terms of, looking at those different materials, and like you said, with NEZO having the ability to compare and do those sort of scenario analysis. How do you factor in where you have, let's say, materials like steel, for example, that could have different sort of carbon footprints or global warming potential values depending on the source manufacturing route? And I guess, how does that account for that variability? Sorry, you're just muted, Barry.
Get there eventually. I'm not used to Zoom. It's our system doesn't work specifically on concrete, steel, timber. It works on a supplier basis. So you do have some generic rates built in there where there's a gap in the market, but where you say you want your timber from a specific supplier, we have the ability to do that. So it's coming directly from the EPDs that are produced by the suppliers, not by just a generic location that all your timber is coming from New Zealand, and you're ignoring the fact that it's come from Australia or coming from Europe. So all of that is built in. You can actually choose where your supplier actually comes from. And we use the NECO2 database here in construction for New Zealand, which is run by MasterSpec, which took over from Brands. So we're hoping to see some major updates with new materials come in there, because what we're seeing is the industry kind of went stagnant, or the EPD information went stagnant for about 2 years, when in that transition of government and transition of Brands to MasterSpec, they've now improved the efficiency of how they do it. Or how they present it. So hopefully in the next couple of months it starts to speed up. What we do know is that there's a lot of EPD and suppliers with EPDs in the market that are not on the database because of that stagnation and just inability to get on the database. But that's surely going to improve over the next couple of months.
Awesome. Thank you, Barry. Andre, I might jump over to you. So just when it comes to, like you said, using AI, and there's a fair bit of data that you've done with sort of different biological systems when you're modeling your LCAs, where have you found, I guess, areas that you have to sort of spend a bit more time to do that sort of triple checking, human checking as well?
Yeah, well, we do some checking and flags on, and that was mentioned before by others here, the input data, because that's key and that's what's driving most of our changes and things on the model. So having a system to flag saying, oh, there's too much fertilizer here. Are you sure there's not an extra zero or something like that? This is one of the key sections that we can use the help of AI and create those types of flags and create the relationships between how much pasture is growing, how much the animal is producing. Is that does that make sense? Of course, you can do that yourself as well, but AI make things easier. And at the end is trying to identify main hotspots, as was mentioned by Andy before, but also trying to identify outliers and saying why is this outlier here? So why is so different from all these other hundreds of farms? What's happening here? Make things faster, and instead of us having to dive on all the data, flags saying, oh, you should look at this input or this emission factor or this type of thing. So that's where we've been exploring mainly.
Thanks, Andre. And I guess in terms of, gaps in current sort of data that's out there as well for New Zealand specific ones, this will also be applicable, for Andy and Barry. Where do you see the biggest gaps are at the moment in terms of these sort of data sets that are required, and how does it sort of affect the AI use?
I can start. The main one we've seen people getting more interested on scope 3 emissions and collecting more and better data over time. I think depending on the industry, we have, for example, the dairy industry feeling the pressure of their customers and needing to report they are much better than, for example, or in a better state as the beef and sheep industry that to collect data and help with that. So the use of AI there could help this other industries such as beef and sheep with what we mentioned before, getting those invoices and scraping data from that, making the farm easier for the farmer to provide the data to the LCA practitioner neuroscientist. I think that's the biggest one in the area that we are working, is making the life of the farmer easier so they can do farming, which is what they are very good at, and we can have good data for providing them with the results.
Yeah, my first point, I guess, kind of already said it, but just the unlocking of available EPD that is out there at the moment. We were just stagnating for the last 2 years. I think what the biggest fundamental difference will be policy and support for the industry to actually do this. Like you look, I think it might be the UK, the policy they have there that your EPD is used within the construction process for analyzing the carbon emissions. But if you don't have an EPD, you have to use an alternative competitor, plus they add a weighting on it. So there is a push then for the industry to go get an EPD if you don't have an EPD. We don't really have anything like that in New Zealand. We don't really have support for suppliers from government to subsidize the cost of EPD, or a policy that pushes them to actually go do it. But what we have seen is some major players in the industry like Jackson's, Heinz. Obviously, they've got EPDs for all of their products and are trying to normalize low carbon concrete products. The concrete industry is a big pusher of EPD, so is the steel industry, the timber industry too. But when you start going beyond that into material finishes like cladding systems, aluminium, window joinery, things like that, it starts to fall down at that point. So and you tend to be looking at smaller industry, smaller companies, smaller manufacturers in New Zealand. So there needs to be something there to support them, or something at the very minimum to push them to go get their EPDs. Right now, for most of them, the cost is too expensive when there is no mandatory requirement.
Cool. Thank you, Barry. And I guess, Kelly, I might jump over to you. I guess, we've talked around a lot of these tools and also just pulling out, extracting the EPD data. But I guess as it's coming, as it's publicly accessible and getting used by these tools, what is something that you think practitioners and sort of designers should keep in mind with interpreting as well some of that information captured in those EPDs?
Yeah, I think that in terms of EPD use and EPD development, so that there's the two ends of the spectrum, if you like. So I think those that are doing the LCA can definitely use AI to reference, reasonable results. I think is a really good way to use AI through EPD development. And I think there's also a growth in these tools that will assist the development of EPDs. So under EPD International System, the use of pre-verified tools, I think, will make the development of EPDs much more accessible and affordable. And then obviously at the use phase, because we are seeing this explosion of EPD data being extracted into these platforms and tools, is really just to, check the integrity of those third-party platforms and acknowledge that, once it's outside of that formalized EPD document that's been extracted by AI, it's no longer a verified figure. So just to handle that sort of use phase with care as well. Yeah.
Great. Thank you, Kelly. And I think just in terms of time, Barry, we've got one last one for you, and then we might do a recap. But I think there's a question that's come through saying, awesome, Frezzo, and that in New Zealand, some projects do work off 2D plans, for some smaller ones for the initial design, but wondering if, with NEZO, let me just pull this up. Sorry, give me one. Yeah, just with NEZO, can they sort of interface with these 2D plans, or would they need to use a separate AI tool first to build a SketchUp 3D model? And if so, do you have any recommended tools for that function?
Kind of is the answer. 2D plans aren't ideal. You do need a 3D model. But we do have some solutions around that. So what we're doing, and what we didn't discuss, is we are using AI with the permission of our users as well to benchmark projects. So at the very highest level, you can use your 2D plan and have a guide as to how much carbon emissions should be in your building based on building use and some of the material selections that you've got in there, and how that will compare against an alternative construction methodology. It's high level, but it will work off of 2D plans effectively, or just the square meters of your building and a description of your building. The other answer to it is that you can give it to us. We will turn it into a 3D model for you. That's like, we've got a small consultancy that sits on the side of our software business that will take it and turn it into what we call virtual design construction, which is turn your 2D plan into a 3D design and provide it back to you. So yeah, that's fundamentally it.
Great, thank you, Barry. Yeah, and I think just in terms of time, what I'll do is just flick through the last sort of question to everyone. And this one is thinking around, if we were to sort of catch up again in 2-3 years' time, where do you sort of see the biggest changes coming through with AI? And Andy, I might kick off with you, because I know you said, with the tool as well, that this was just the start. Where do you see this changing, and sort of in one sentence, if you could capture it? Oh, Andy, you're just on mute, sorry.
Sorry, yeah. I don't think we can even imagine, honestly, where we will be in 3 to 5 years. I really don't. Just the progress in the last 12 months, almost this arms race of new models being dropped on a weekly basis, and the capabilities that they have. I think the gap is in our ability to use the technology, not what the technology can deliver today, never mind what it can deliver in 3 to 5 years. So yeah, we're always encouraging ourselves to really stretch, and we've never found any limitations on the AI side. It's more our ability to use the AI to deliver value is the thing that we need to be constantly thinking about.
Thank you, Andy. Andre, what about yourself? Sort of one thing that you think would sort of change in sort of 3 to 5 years?
I think thanks, Ray. I think it's mainly what we've been seeing now is the new generation of AI is training itself. So it's not us controlling it anymore. So can we lose control of it? And if you look for people such as Yuval Noah Harari, he wrote *Sapiens* and other stuff. He has been talking a lot about AI recently. This risk of AI going rogue, and we are creating something that is self-conscious. That's bigger picture. For our work, I think what we have from AI is in the future will be like stronger reasoning. Like now, today, you can see how AI is thinking, which is completely different from 2-3 years ago, and fewer hallucinations. I think while it will start gathering more material, there's more things available on the internet. It will be hopefully less hallucinations when there's no data available.
Thanks, Andre. And Kelly and Barry, any sort of takeaways, one thing that you'd like our participants today sort of keep in mind as they kind of continue on their journey?
Start early. Don't wait until you've got perfect information.
That was
It's
good, Barry.
it's not enough to measure, you got to manage.
Yeah.
Mhm.
I guess, yeah, looking into the future, what I think, putting a positive lens on it, I'd like to think that there'd be better decision making based on better data, because we've improved efficiency, we've improved QA and verification, and therefore we're able to make better decisions. Yeah.
Awesome. No, thank you all so much. And I'll just hand over to Jackson now to do a quick sort of recap and share a bit of sort of the poll results as well for those that have completed it. So thank you all. Jackson, over.
Thank you, Ray, and thank you very much again to all of our presenters for their time and wonderful knowledge that they've shared with us today. Looking at the poll, it was amazing to see the range of professionals that we have here today in the workshop. A lot of LCA practitioners, obviously, but also LCA data users, researchers, and ESG professionals. And there was certainly a very common theme around people using AI. I think a lot of ChatGPT and Gemini users out there, but not taking that step to using AI for LCA. So people are getting their familiar with AI. It's clearly here. Hopefully, as Andre mentioned, it's not going to go rogue and take over the world, but it's here. It's a fact of our lives. I'm sure my kids will be using it for the rest of their lives. And there's some very valid concerns raised around having some guardrails for AI, but also thinking about the opportunity cost. And I think reflecting on what all the speakers have said, without AI, most people probably won't do LCA, and is a 90%, 95% LCA better than no LCA? Probably. Even when LCA is done by the best of practitioners, it's limited by the data that's available. And as Andre talked about right at the start, sometimes tracking down the sources of those data is kind of behind a black box or a paywall anyway. And so even if your LCA tool doesn't make that clearer, doesn't necessarily mean that it's worse. So as Kelly mentioned, the ideal is humans plus AI, and we've seen that in both the talk that or the tools that Barry and Andy presented today, where those are brought together. Humans still have the ability to interact with the AI to increase the accuracy, accessibility, and the cost of life cycle assessments. Is going to be a great thing for all of our industries and the LCA in general. So hopefully people are going away feeling positive around everything that's been done today. As Andy mentioned, AI is just changing so fast. It's hard to predict what's going to happen in the future, but the best thing we can all do is talk about it, understand it better, share, and try and use it in the best way we can. So again, thank you to everyone that participated today. Thank you all the people that listened in. We will post a recording of this on the LCANZ website for any of your colleagues or friends that might have missed it. Thank you, everyone, and have a great day.
Thank you, Jackson.
Thank you.
Thanks,
Thank you for
everyone.
organizing, guys.
Thank you.